This lesson is for Unit 4, Lesson 7, Common Factors of Polynomials. So greatest common factor for a monomial factor is what you're looking between the two terms, three terms, however many terms there are. You want to look at the greatest common factor between the coefficients. So in this case, we want to look at the greatest common factor between 10 and 16. And then we also want to look at the variables. Now for the greatest common factor for the variables, it's going to be the highest exponent value that they both share. So you would be comparing the x squared with the x cubed. With this one, for example, they both have at least an x squared, so that x squared is going to be part of our greatest common factor. With the y's, y cubed and a y, they both share at least a y, so that y would be a part of our greatest common factor. But looking at our coefficients, we have a 10 and we have a 16. If you know right away what they both have in common, the highest factor they have in common, you can identify that. Otherwise, you might just want to factor it out. So 10 factors to 2 and 5. 16 would be 2 and 8, or 2 and 4, and then 2 and 2 again. So factoring out to prime factors. So this one has a 2 and a 5. This one ended up with 4 2's. So the greatest amount that they have in common is just 1 2. So the greatest common factor between 10 and 16 would be a 2. Looking at our variables, x squared and x cubed, they both share at least an x squared. So that's going to be part of our answer. And for our y's, y cubed and a y, they both have in common at least this y. So here would be the y value. So this right here is the greatest common monomial factor between these two terms. You want to compare the coefficients and each variable. Looking at this example, this one now is 3 terms. So start off with just your coefficients. We've got a 12, an 18, and a 24. So you can factor them out. Otherwise, if you know your multiplication facts really well, you can think, so this one simply is 12 or 6 times 2. This one I know there's a 6 that goes into 18. This is 6 times 3. And I know there's a 6 that also goes into 24 because 6 times 4. So the highest that they actually have in common is 6. So between 12, 18, and 24, 6 is the greatest common factor between those three numbers. Now looking at our variables, I've got an x cubed, an x squared, and an x to the 4th. All three terms have an x term. And the smallest of those is this x squared, so they all share at least an x squared. So that's part of my factor, my monomial factor. Looking at our y's, we have y to the 5th, y cubed, and y squared. So all three terms have a y value. The most that they all share in common is this y squared. And the last one, I see some variables of z up here. This one has a z squared. This one has a z, and this one actually doesn't have a z, so it's not part of the greatest common factor because not all terms have that. So this would be our greatest common monomial factor between these three terms. Adding on to that, if we have to find it and then also factor it out, we're still doing the same steps that we just did, where you find that greatest common factor, but you're also then dividing it out of the terms that are listed. So first, again, find your greatest common factor. So between these two coefficients, I have a 26 and a 78. Just looking at these two, I don't know right away what's in common, but I'm going to start with this greater number. If I factor this out, if you factor out 78 and let's say I divide out a 2, you end up with 39. And 2 is prime. If I divide out 39, 39 is 3 and 13. All of these are prime numbers. So then if I factor out 26 and I divide out a 2, I would have 2 and 13. So looking at these two numbers, they both share a 2 and they both share a 13. So they actually both share 26. So the greatest common factor between 26 and 78 is going to be 26. Now looking at the variables, x cubed times x squared, they both share an x squared. And then y to the fourth, y to the fifth, they both share a y to the fourth. So here's our greatest common factor. Now if I have to divide it out of each of these terms, think of it as, so you're still going to have part of your original answer. We're just going to divide out our greatest common factor. So dividing each of these by a 26x squared y to the fourth. So 26 divided by 26, those two cancel out. X cubed divided by x squared, that means we still have an x in that term. Y to the fourth divided by y to the fourth, those two cancel out. So all that's left in this first term is 1x, because these two cancel out with one of those. So this term is just an x. 78 divided by 26 is a 3, so we have a plus 3. X squared divided by x squared, those two cancel out. So we don't have an x left over in this term. And then y to the fifth divided by y to the fourth, those cancel out. We're left with just a y. So here is our complete answer. We can see our greatest common factor on this outside part. And then when we divide out that amount from our original problem, we're left with an x in our first term and a 3y in our second term. So for these types of problems, find that greatest common factor first and then divide it out, but make sure in your answer you rewrite it so that you've got the greatest common factor divided out and whatever is left over inside your parentheses.